Sometimes we'll see an argument that matches a familiar form almost. Now, when we have something like that that almost matches a familiar form, we could go to a new truth table, but it turns out that that's not necessary. Let's try analyzing this argument without going to a new truth table. So this argument says, if they write a term paper, students do not need to take the final exam. David, who is one of the students we're talking about, needs to take the final exam. Therefore, he did not write a term paper. So, our premises are, if they write a term paper, students do not need to take the final exam. David does need to take the final exam. And therefore, David did not write a term paper. And as we usually do in cases like this, we notice that the first premise applies to David. And so we can use the simple statements, David writes a term paper, we'll call that P, and David takes the final exam. Our first premise, if they write a term paper, if David writes a term paper, then he does not need to take the final exam, will be if P, then not Q. Our second premise is that David does in fact need to take the final exam, so just Q. And our conclusion is that he did not write a term paper, so not P. This looks almost but not quite like one of our conditional-based argument forms, of which we have 4, right? We had direct reasoning, indirect reasoning, denying the antecedent, and affirming the consequent. Let's see if we can narrow this down. Looking at our argument, our second premise is Q, which appears in the consequent of our argument. Q appears in both the consequent and the second premise. We have 2 argument forms where the same simple statement appears in the consequent and the second premise. The argument that we're trying to analyze is going to match either indirect reasoning, which is a valid form, or affirming the consequent, which is invalid. Okay, so as you practice these, it will become obvious which one this matches, but there are 2 moves that we can make that will let us transform our argument into the form that it's ultimately going to match. And these 2 moves are both legal because of the effect that they have if we were to make a truth table. So the first move we can make is to take our argument, if P, then not Q, Q, therefore not P. The first move that we can make is to replace any statement by an equivalent statement anywhere. The reason that this move is legal is because when we replace a statement by an equivalent, well, that has no effect on the truth table. That's what it means to be equivalent. And let's see. Well, the thing that's causing us trouble is that we've got a not Q here and just a Q here. So maybe what we'd like to do is to replace our Q. Well, we'd like to have a not Q. Those aren't equivalent. Let's try a not Q. So we're going to replace our Q in our second premise by a not Q, which is equivalent. And then we'll leave everything else alone. Hey, that's actually pretty nice, because now it looks like, I'm just going to copy the form our argument is in right now. Now it looks like what we have is not Q showing up twice, and one of those is negated. That gives us our second move. We can replace any statement with any other statement, as long as we do so every time it appears. So we're going to replace every appearance of not Q by Q. And we'll make sure that we don't have any appearances of just Q. And what that actually does is, if we were looking at the truth table, that just changes the order that the truth table rows appear in. So, replacing the first occurrence of not Q, we'll get if P, then just Q by itself. Replacing the second occurrence of not Q, we'll get not just Q by itself. And then we're not doing anything to this final not P. Okay, after all that manipulation, we look back at the list, we see that this is the one we ended up with. Our argument ends up matching indirect reasoning, and indirect reasoning is a valid argument type. Now that second move we have to be careful with. Essentially, it was necessary that everywhere that Q appeared, its negation was being replaced by itself. Otherwise, we could make a little bit of a mess. So, if we had a statement with a Q and an R in it, we would need to replace everything that contained a Q or an R. So we have to be very careful with this move. The move where we replace something by an equivalent, we can do extremely freely. Now, this process might seem a little bit tedious. We just went through an awful lot to avoid making a relatively simple truth table. As we get more accustomed to this, you will not need to write out every individual step. You'll be able to just look at an argument form like this and see that it's actually the same argument form as this. So we really do save a lot of time by looking at the forms. Even better, we'll be able to use a relative of this process in order to analyze much more complicated arguments than this one. And that's what we'll see in the next two videos.